Welcome to our webinar about adapting to the cloud. I'm in case anyone doesn't know, I'm Helen Whedon, the Managing Director of the Satcoms Innovation Group. So we've got a great panel lined up today. We've got Alvaro Sanchez from Integrasys. We've got Paul Isaac from Kratos. And we've got Bill O'Hara from Intelsat. So we're going to delve into some conversation about adapting to the cloud for Satcoms. If you have any questions or comments throughout, please pop them into the chat. At the end, we'd welcome some discussion and questions, so that would be great. So for now, let's delve into the discussions with the three panelists. So what I wanted to do was kick it off with a question for all three of you. Perhaps Bill, if you want to take this one first, and then we'll have the same question to the other two. So my starter question is, in your mind, why does the Satcoms industry need to embrace the cloud?
Great, and again, thanks for having me. Bill O'Hara here, VP and General Manager of Media at Intelsat. So I can't speak for others, but at Intelsat, what our biggest strategic imperative is being an integral part of the broader telecom fabric, the broader telecom industry. And really what we've experienced is that telecom industry, continues to change, continues to adapt. There continues to be new entrants that are providing serious scale and new capabilities in that broader telecom fabric. And cloud service providers, especially the large ones, absolutely are the new big players, coming into that broader telecom fabric. And so it makes all the sense in the world for us to partner strategically with them, to integrate with them, and to provide better services and on-ramps for and off-ramps for our connectivity through those cloud service providers.
That's great. Thank you, Bill. So Paul, do you want to take the same question from your point of view?
Sure. So again, thanks for having us here, Helen, today. My name is Paul Isaac, working for Kratos as product line manager for the RF monitoring products. So when we look at what's happening in the industry, I think we definitely echo what Bill said, that the scale and flexibility is required. Users are expecting connectivity. They don't distinguish between cellular, Wi-Fi, or satellite. And in this hyper connected world, the solutions really need to be transparent. So hardware is expensive, it's time consuming to scale, and really the global telecom and cloud industries have proven it has the technology to scale. We should look to adopt those technologies in our industry.
Great, thank you. So Alvaro, same question. What's your take?
Thanks, Helen, for letting us join this conversation for us. Cloud is critically important. We're a software company, and we have been a software company since 1990. So this is an evolution in that regard, bringing what it was hardware into software. So it's a market, and it is very important because nowadays we can do compute a lot of the signals, a lot of the content, and enable new applications as well. So as Bill said, new kind of customers are getting into the satellite arena, new kind of content is getting into the cloud, and new applications that are rising in our industry. So it is important that satellites get integrated into the cloud service, as well as we utilize the cloud for providing better solutions to customers.
Great, thank you. Good insight. So, so Bill, back in 2019 was when Intelsat and a few other operators first partnered with Microsoft to connect remote customers directly to Microsoft Azure cloud network. So do you see that as having been a turning point for moving to the cloud? And how has the view of cloud-enabled satellite changed since that point?
So I think that the connectivity partnership with Microsoft was actually more symptomatic, I guess, of our feeling that I described earlier, that there really just had a critical mass of scale had absolutely been achieved, and customers needing these types of cloud services capabilities, whether remotely connecting to the cloud or for the origination of services that they then distribute over satellite. Seeing the type of scale that had been achieved by our cloud service providers in really a subset of the total global telecom market was, I think, really what pushed us over into really understanding that this needed to be a very strategic part of our roadmap. And what I mean by that is that the massive scale has been achieved by our cloud service providers has really only been achieved in the connected world to a large extent. Obviously, one of the big benefits of being a global satellite communications platform like Intelsat is that we do a lot of work connecting the unconnected and providing connectivity services in areas where it might not be so native to have cloud services available to you. So I think that for us, it was the aim is to partner to connect the unconnected and where we can provide the most mutual value and bringing these services around the world. So to kind of sum up, I think the notion is that we saw what was the art of what was possible in the connected world by the rapid scale that had been achieved by major cloud service providers. And we realized it was a very logical fit for our strengths, which is connecting areas, whether it's on airplanes that's hard to connect, or cruise ships, or in underconnected areas of the world.
Okay, great. So so obviously there's been quite a lot of technical innovation over the last few years. So Alvaro, what would you say are the biggest innovations that we've seen, and how do you see that changing over the coming months further?
I think that the biggest innovation is Zoom, and that allow us to communicate over the cloud as we are doing. And the second biggest innovation is beam budget. So that allows to still do business in satellite and still do cell capacity and still make a more streamlined process on the commercialization of satellite capacity and service in a more seamless manner and a more easy to use. So what we are saying is that cloud tools are mandatory for this new world that we are living. The world has changed. Nobody is traveling. Nobody is getting into the cruise lines or into the airplanes, which is the same for our industry. But there is another traffic that is, in many cases, a cloud traffic that enables the remote and digitally by the populations to connect to Microsoft or any other platform such as Netflix or any media platform, because at the end of the day, the media is in IP, it is in cloud, and we need to broadcast the information to all the users that require that. And it is critically important that this kind of platforms, whether it's Zoom, WebEx, or tools that enable you to keep doing good business, to keep selling the capacity, to keep being profitable companies on the satellite domain, makes a good year like 2020 or 2021, and continue to be established the satellite arena and the satellite industry within, instead of reducing the investment in that satellite capacity. The satellite the traffic in general is increasing thanks to this COVID situation that we cannot travel and move freely. We cannot have meetings in person with customers, etc. So we need new tools and we need to adapt. And the ones that do not adapt, they won't be performing as they have been in the past.
Very good point. So the other thing is that with the satellite technology advancements that we're seeing, they need to be matched by ground segment improvement. So I'd like to hear from Paul how the ground is taking advantage of the cloud, virtualization, and other technologies?
Yeah, so, when we look at how static the ground station's been, and, embarrassed to say, in the industry over 30 years, the basic components are still there that I started working ground stations 30 years ago. It really is ripe for change, and to take advantage of the high dynamic payloads, the new orbit planes that have been launched. The ground station needs to take lessons from what's seen in cellular networking and global telecom. And to that aim, Kratos believes the industry needs to deploy ground platforms on the core fundamentals of network function virtualization, software-defined networks. And in this way, we start to get the benefits of scale beyond what can be accomplished with hardware, and even beyond what can be done with just virtualizing software in containers. To enable this, the RF is digitized as close to the antenna as possible, and it's packaged in a standard like Beta49. These digital samples can now be moved over standard IP and essentially to any data center running in the cloud. When it comes to processing these samples, Kratos is approaching this with a mindset that traditional physical ground station components like splitters, combiners, modulators, and demodulators, these can be virtualized into virtual network functions. And these VNFs run on standard x86 compute, which is cloud native. These run already in public solutions like AWS and Azure, or in private cloud environments. So as new requirements come in, whether that's a new service expansion, whether that's a downgrade, these VNFs can be spun up and down to meet the needs of the new data requirement. And this is done through organizing them as service chains, which is an SDN term. A controller is unable to instantiate the service chain to meet this revised requirement. And once it's up, it can be monitored through its life cycle. And that could be a few minutes for a LEO orbit, or it could be many years for a GEO. Of course, we can't virtualize all components. Some of them can't live in the cloud. So things like antennas, amplifiers, and frequency converters, they're still required. But it's important that management system, something like what Kratos provides, it can bridge across the virtual and physical components for the service chain. And then provide configuration, control, and reporting on the service performance end to end. So we see some very large changes happening in the ground station that will make it very flexible and very dynamic and set to be able to support the new payloads that are being launched.
Do you see that as a big leap to get to that point? Or do you think that it really isn't, it should be quite a smooth transition?
So everything is a challenge when you change the dynamics of something that's existed for 30 years. Well, I'm beyond, of course. But we are seeing vast technology changes today. We're already digitizing the RF. We have technology that does that. We can get it to IP. We already have software radios vastly used in industries. So the technology is there, putting it together, and along with platforms that exist in global telecom, it's not a huge leap. It is a bit of a leap of faith, but it's not a huge leap in technology.
So from an operator point of view then, Bill, what do you see as the challenges that are still in place for satellite operators to move to the cloud-enabled approach? And where do we need the biggest amount of innovation to make that, to overcome those for you?
Yeah, so I think probably three different areas, and Paul really just hit on one of them. Just the whole RF IP kind of juxtaposition of what's going on in the teleport and the uplink and everything before that that's occurring on the IP side. That integration and making that as converged and as harmonized as possible between the different workflows is really a huge point going forward, as Paul I think very eloquently was discussing. beyond that, we look at everything through the lenses of our customers. And in the media business, just as an example, so many of our customers are moving their content origination services into the cloud, away from their traditional playout that might occur in their own facility-based playout. And they're doing this for a variety of reasons. I think actually during COVID, some facility-based playout was exposed a little bit due to staffing and manpower, whereas cloud-based services were pretty robust and rock solid from being able to remotely access. But as our customers are moving these things to the cloud, they're really changing their network infrastructures, and they're changing the way that they operate their workflow and how they integrate with traditional distribution methods, such as satellite distribution to cable head ends or DTH or DTT, whatever it might be. So with these pretty significant network infrastructure or architecture changes, kind of the old way of doing things, or the standardization that had occurred with their previous workflows, is not entirely replicable across this new way of originating content and bringing it to teleport. So I think that's something that we're working really hard at to really standardize the connectivity of the network, bringing the content, which is extremely high value content that people are, our customers are monetizing this content as their livelihood, as their lifeblood of their revenue, making sure that it is as reliable or more reliable as the traditional way that we had originally sourced the content. And then, I think lastly, as we're moving into different workflows, a big innovation that would be really beneficial, that I think would be fantastic for the industry, would be to try to get on a single pane of glass as you're starting to look at the workflow from origination all the way to distribution. You're talking about a pretty bifurcated network, one that is teleport driven, uplink, but also cloud sourced and often third party fiber. These are, again, newer ways of connecting with our customers. So the more converged and harmonized we can make them, I think would be big innovations that would help drive the adoption.
As Bill said, it is curious how cloud enabled few opportunities like infrastructure as a service that he was referring before, where as software can be virtualized, it is much simpler to provide a service. We are saying that cloud is one of the best platforms to provide software as a service. And it enables few markets where, for example, LEO and MEO constellations cannot afford to deploy a large number of hardwares throughout all the gateways they need to deploy. As Paul said, the antennas are mandatory, the boxes are mandatory, as well as the LMBs. But however, the most of the devices can be virtualized as soon as you have the RF over fiber. So in this RF over fiber, you have a wide range of layers that you can build software and that you can monitor capacity, that you can monitor spectrum, you can automate a lot of things, as Bill mentioned. We just developed a new set of APIs for all the products in order to have an end-to-end system, in order to automate the full chain from the design phase, deployment phase, maintenance phase, SLA certification, as well as interference detection and cancellation. So all the full chain of products we have with the APIs in order to have machine-to-machine integration and a full end-to-end system. So which covers all the satellite operator needs as well as service providers. So in this case, they can be more effective, less human factor and less work. So more tasks remotely and less, let's say, an unmanned teleport can be accomplished.
So how does that? So you're saying a lot of high premium content. What does that mean from a security point of view, when you move to the cloud, is that kind of make it more of a concern? Is it easier to manage?
Well, so for our media customers, I think we're very well known for our closed networks, and this will continue to a large extent with our cloud integrations. Private VPN on the IP level for our interface with the public cloud, and then private fiber and enclosed media grade fiber leading all the way to the teleport. So this is absolutely a concern for our customers. It is something that is high visibility, obviously, in today's day and age. And again, this is the lifeblood of our customers' revenues. This is how they monetize their content, and the pay TV ecosystem is still the driving force behind that monetization. So it's something that we take incredibly serious, and that we really work with our customers to design connectivity solutions that work for their standards and infrastructure, as well as for our own high standards. But it's absolutely a change from the previous networks that we would have with a customer, where it would literally be a private connection, literally from from their facility all the way through to our private fiber and teleport and uplink. So that is absolutely something that we want to be very conscientious and diligent about. In other parts of our business, I think we view it as an opportunity to provide more security for our customers. So as folks are accessing the cloud, perhaps from more unconnected areas, maybe a full portfolio of security services isn't necessarily something that is available for them, locally for them there. But if they're using the cloud essentially as their access portal to the public internet, then being able to provide virtual firewalls and security services there is a way that we can better serve our customers.
So, Paul, what lessons can be learned from stuff that's already been done with Earth observation and GSAS providers that have already embraced the cloud and virtualization technologies? Then,
yeah, there's a couple of points here. And Alvaro alluded to a couple of them there, that the EO and the ground stations as service offerings, they've really validated that information or samples should be processed where it's most cost effective, utilizing a scalable ground network coupled with cloud technologies. The traditional method was for each Earth observation company, they build out their own dedicated ground station. And then the raw data was moved over less than optimal data links to be processed at customers' facilities using their own compute. The new offerings from Amazon and Microsoft really position the antennas at the data centers, allowing for that raw compute to be available to process the information directly on cloud infrastructure. And then the users can just retrieve the images already processed. So contrary to the traditional dedicated assets, the utilization of the antennas at the data center, they can achieve a wider range of missions with greater utilization. More people are using them, more people are scheduling them. And it's only really software to reconfigure at that point, versus potentially bringing in new hardware at specific locations for a legacy solution. And then the other key part that we take away is the adoption of open industry methods for orchestration of services. I think adopting open standards is really key to allow the gateway as a service or a private gateway to fulfill roles within a complex network. As Bill mentioned, there's going to be a blend of where you use the web services and also private gateways. These standards are not new. They've been widely used in cloud industry and also in telecommunications and wireless. VNFs, the virtual network functions, they adopt Open API. The network service definitions that build up the service chain use Yang models. And then you use SD-MANO for automation or autonomous networks. And really, open standards is key to embrace a cloud native environment to deploy services. Without it, you're going to have the same problems that we've had in the industry already. We need to learn from the 2G, 3G, and 5G and adopt open standards. Kratos is very much on board with that. In fact, we named our product Open Space to match the open and open standards.
So Alvaro, what do you think are the next steps to make satellite more cloud enabled? What should we be doing next?
So we need to upgrade the infrastructure. Just kidding. We are a software company. We have been working in software products and monitoring products. We do not do hardware. We have been always reutilizing hardware, external hardware, and we plan to do that. And we plan to be in the cloud, integrated with the cloud, and with cloud customers, where they utilize our systems to measure and monitor and automate in a seamless manner for our typical customers, which are telcos, that they use all these standards, that they have a lot of experience with IP traffic, and that we serve today. So, and we have a set of products that make them more effective and make their operations more seamless in that regard. We will continue to support our RESTful APIs products that enables machine-to-machine integration with cloud tools as well. So this way, any equipment within the network can be monitored from the cloud, and we can automate even further in all the networks, whether it's a broadcast network, whether it's IP network, whether it's any kind of network in a secure or in a more public environments. So it is what we see, that cloud is an enabler to a wider traffic, to a higher demand, as well as it is an enabler to provide products in a more seamless manner and in a more automated manner, as well as integrate with those frames that enable us just software monitoring that we are quite interested in.
Thanks. So, so Paul, how operations going to change on the ground potentially, and what does that mean for things like how, for example, how interference is handled, would you say?
Yeah, so we think the operational concepts will change as providers deploy and report on the service chain SLAs. The advantage of having a flexible, scalable ground station is you can react faster to issues that impact the service. You may have the ability to change the service ingress or egress points to avoid the interference, or even change frequency plans to null the impact. Traditionally, when a service is impacted by interference, the first step is to restore service, whether it's increase power or find a new frequency allocation. That could take a lot of time for users to look at frequency plans and work out where to move to. It could be essentially automated in the future based on what capacity is available, what the ingress points are available, what egress points are available. So traditional RF tools that have been deployed, they've been deployed when gateways are built. Engineers would view the alarms that are generated. They would interact with them. They'd troubleshoot bandwidth in real time. But with cloud-based software-defined services, you can layer in VNF functions for analysis or interference detection. And in this way, an issue that could be raised based not on just service throughput or latency, we could also qualify the RF link. And this can point the operator to where the issue is, or even trigger a mitigation plan. So when RF impacting scenarios are detected, interference, as an example, or even rain fade, similar to a network industry having more analysis probes within their service, we can start to lay that within our RF links as well with the RF tools. And that allows us to automate through machine learning and determine mitigation plans, just based on the metrics we're picking in the service. So being able to provide that end-to-end visibility of the service throughput and any issues that affect that.
And just a further comment on that. I mean, I think that's tremendously important as everybody's trying to scale, right? And as we integrate more with cloud service providers, as we continue our integration, with the broader telecom industry, it is a matter of scale. And the ability to automate is incredibly important. The ability to move away from a world where you have an engineer monitoring alarms and doing SOP checks and things like that and more towards a world where you have an intelligent system that is dynamically provisioning or troubleshooting or using business rules to react to a situation is absolutely an incredibly important part of I think part of the industry's roadmap for sure.
Yeah, there's another point there as well, Helen, regarding the way that RF tools and these probes have been built traditionally. The physical devices, whether physical digitizers, visual spectrum analyzers, but if they become VNF functions, it allows the customers to deploy RF tools as their business changes, rather than building out that infrastructure right at the beginning, or even potentially lagging. What we see is customers will turn on bandwidth or turn on beams, and then they scramble to put monitoring assets in place. But if this is now virtualized, if this is software defined, then they can potentially just switch this on as they need it. And it's not, at this point, it's not going to be CapEx heavy. They don't need to come up with the CapEx to deploy the large monitoring system to start with.
As it is a P, it can travel anywhere, anytime, and it can be computed anywhere and anytime. So it doesn't need to be in any way heavy in infrastructure. So this enables Leo and Mio to have very light gateways, which enables to close a lot of business models for these new constellations, as they don't require huge CapEx at the start, and they can pay as you grow with services in top of that hardware infrastructure in those very light gateways. So this makes very, very affordable for those Leo and Mio constellations that are starting to rise, and they are able to close their business models and don't go bankrupt.
So before we open to the wider discussion, which I think would be good to do now, I do have one last question, which, to be honest, you've touched on, but maybe you can all just sum up what you envisage as the future satellite workflow. Let's start with you, Alvaro, this time around.
We envision end-to-end, in just few words, all automated, no human errors, less interference, and well mitigated, as well as a lighter and more OpEx-driven industry. We have seen it in customers demanding that, and we are providing. So, and we will continue to provide in a more seamless manner, more automated manner, and enable them to not only save cost, add additional revenue streams to those content providers, to those telcos, and to those satellite operators, that they utilize our products to be more effective, not only in the operational expenses that they save, also in the new revenue that they are managed to accomplish.
Great, thank you. So same question to you, Paul.
Yeah, I have to agree with Alvaro on this. Automation. To really scale the networks, automation's key. It'll, to create that potential blend of orbits, LEO, MEO, and GEO, services based on SLA parameters like throughput and latency. There's no real true way to scale without automation. And that really includes satellite payloads. So big data analytics, machine learning, also change that workflow and support the automation that's needed.
Nice. Bill, anything to add there?
So I have the unenviable task of saying something different. No, I mean, those things are I'm in violent agreement with what you guys just mentioned. slightly different, perspective, from where I sit. But I think that it's possible that we could see some amount of multi-tenancy moving into the teleport. So the notion of moving components of the cloud closer to the actual teleport. There's various reasons why this might be interesting, from removing some connectivity challenges or reliability issues or concerns, especially in situations where the workflows are fairly well defined. And the amount of compute obviously is usually the limiting factor with making it scalable. But I think that could be an interesting development if you started moving the capabilities closer together in actual geographic proximity. I think that might provide some additional value to our customers.
Great, thank you so much, all of you. Does anybody? So great panel. Thanks both. Thanks all three of you, Alvaro, Paul, and Bill. I'd like to open it up to anyone that has any comments, questions, anything that opinions they want to air. Feel free to chip in.
I have a question for Bill.
Okay,
for me. Oh, great.
This way we can interact a little bit. How do you see Netflix going to Intelsat and ask for bandwidth in the regards of what do you see they do care on the Intelsat business case or in the Intelsat networks to provide? Sorry for the question, it was not prepared.
Yeah, well, I mean, this is obviously, leaving aside Netflix, but the notion of major content providers, and as we all know, I mean, Disney, has a similar offering, and others have similar offerings, and many of them are customers of ours, today. I think that what I find to be most interesting about this situation is some of these providers have found it challenging to scale in certain parts of the world because of CDN costs. So because of content delivery networks, especially third-party CDNs. So those such as Netflix have gone out and built their own CDNs, and they, the OCA appliances that they have, and they're essentially little mini Netflix libraries all around the world. They have found a way to make it mutually beneficial with the local ISP that they install these appliances at, such that for the most part, they're not paying for connectivity. So, they put the appliance at the local ISP, and the ISP no longer has to provide all of the upstream requests for Netflix content, which relieves congestion on their network. And it's very mutually beneficial for Netflix to be there and to also not have to pay for any connectivity to fill that cache. So they've managed to find a way to scale around the world and globally because they've built out their own private CDNs. There are others that I think have found it challenging to enter markets where CDN costs are prohibitively high for the amount of volume that somebody would stream. Latin America is a reasonably good example of this. There hasn't been massive adoption of, to the extent of other areas, in large part, I think, because of, content delivery costs. So I think that there is an opportunity with what we do really well, which is multicasting content, taking one file and blasting it out to some innumerable amount of locations where it can then be cached or rendered locally for someone to view. I think there's a way that we can provide similar value without having to build out a private CDN with terrestrial infrastructure, which can be very difficult. So I think that those are kind of the ways that we think that we can provide the most value. It's kind of the way that we do right now. Our biggest business at Intelsat is distributing content globally to remote locations, whether they're cable head ends in Latin America, or whether it's directly into homes in Africa or in India, or wherever it might be. That is what we do the best, and I think that a similar model could be utilized in the space for IP-based content.
Thank you.
I wish I had a tough question for you now.
Feel free.
Hey, Helen, this is Mark Steele. Can you hear me okay this time?
Yes, I can, Mark.
Okay. So first of all, thank you to all the panelists. That was very interesting to hear their views. I guess the one question I would probably ask to all of the three panelists is there one specific thing you would like to see the user terminal manufacturers deliver that they're not today?
Terminal that joins the network like the iPhone does.
I've already got that, Alvaro, in my new role, but I've moved to microAnt.
Okay, congratulations.
On the antenna, they're big antenna developer here in the US.
Very nice.
So yeah, I've gone in as the MD, so looking forward to it.
So if you need us, so you know where we are.
Oh, absolutely.
So I think, Mark, from our perspective, I think what we would like to see from the terminal providers is IP output. Reduce the requirement for any frequency conversion. So essentially, instead of looking at an L-band output, we're looking for a standardized IP output, and that way it could then be routed way more flexible than having to put more hardware plumbing in.
Okay.
So that's an interesting one, Paul. I think we're fairly well known for pushing for a universal modem that really doesn't discriminate too much between new tech, iDirect, on and on and on. That is a limiting factor, I think, today. And I think that if there was a way to harmonize that, that would, and obviously there are complexities. I understand the reasons why there are, but I think that would drive the industry to some growth.
Yeah, I think it's it's an interesting area that I think needs a lot of discussion because the modem manufacturers are actually quite challenging. Apologies if any of them are on the call. We fairly well cracked certainly the wideband capabilities of a terminal, especially at Ka band, being able to do 3.5 gigahertz, dual pole, wideband, all of those good things, and multi-satellite. But if we want to go into that true mobility where the satellite terminal can actually roam from one satellite operator to the other, different modem networks, that's where it becomes challenging, and you start to see terminals that have, in some cases, I've worked on terminals that have had 4 modem architectures attached to the user terminal to allow that roaming. And of course, the challenge is that it brings that, the argument is always, well, yeah, but they're always looking for the least cost routing. And that's a big challenge. But certainly, we're looking at the implementation of SDRs, where if we can get the buy-in from the modem manufacturers, which I think that's one area that really needs to be focused on with those modem manufacturers to try and get them to agree on a path forward to do that, because it is definitely one of the top things on the top list of requirements. And unfortunately, from a terminal manufacturer point of view, we can't meet that requirement unless it's a really expensive, complex terminal. Yeah, I know. Believe me, it was bad enough. It was bad enough trying to get a standardized antenna set of requirements in SOMAP. I mean, that took nearly 6 years with 4 manufacturers or 4 satellite operators to come up with an agreed standard.
Mark,
So,
don't say no. Don't say no to your customer. Find a way to do it.
Don't worry, we're working on it. You might be surprised.
Very good, very good. I look forward.
All right. Okay. Thank you, gentlemen, and Helen. Thank you.
Thank you. Thanks, Mark.
Thanks, Mark.
So before we wrap up, has anybody else got anything they want to raise? Questions? No, let's take that as a no then. So thank you so much, everybody. Thank you to the panelists for your insights, and thank you to everyone that joined. And
Thank you very much.
Have a
Thank
good
you
rest of
everyone
your
for your
day.
attention.
Thank you for your time.
Thanks.
Bye.
Bye-bye.
Thanks, everyone.